Here we have a rectangular garden that has length x plus 5 meters and width x plus 3 meters and is covered by grass except for a patio area measuring 6 by 3 meters, and we're told the area of the grass is 150 meters squared. So the area of grass would be the large rectangle minus the small patio area, so that would have dimensions x plus 3 times x plus 5 minus 18, and we're told that that's equal to 150. So what we need to do here is to multiply out those brackets to get x squared plus 3x plus 5x plus 15, and then I subtract the 18 equals 150, simplifying the terms and moving the 150 to the left hand side by subtracting it from both sides, we get x squared plus 8x minus 153 equals 0, and that factorizes as x plus 17 times x minus 9 equals 0. So we know that the answer is either x equals 9 or x equals minus 17, but of course it can't be minus 17, that wouldn't make sense in the question because the dimensions would be negative, so the answer must be x equals 9. Here's a tough GCSE quadratics problem. In this one we've got a right angle triangle with side lengths of x, x plus 3 and x plus 6. We want to write down a quadratic equation for x and then solve it to find the side lengths of the triangle. Because it's a right angle triangle, we can apply Pythagoras theorem to give x squared plus x plus 3 squared equals x plus 6 squared. Then we multiply out the brackets to give x squared plus 6x plus 9 equals x squared plus 12x plus 36. After a little bit of simplification, we get the quadratic equation x squared minus 6x minus 27 equals 0. So to factorize that, we're looking for two numbers that multiply together to give minus 27 and add together to give minus 6. And we see that minus 9 and plus 3 work here, so we get the factorization x minus 9 times x plus 3, giving us possible solutions of x equals 9 or x equals minus 3, but of course minus 3 won't work here. I can't have a negative length in the triangle, so the answer to the problem in context must be x equals 9, and that gives us the lengths of the triangle as 9, 12 and 15. That's a scale factor of 3 applied to the 3, 4, 5 triangle that you might know as a Pythagorean triple. This is a tough GCSE quadratics problem. Here we've got a shape with right angles at all of its corners, and the area of the shape is 54 centimeters squared. There's a few ways you could split this up into different rectangles. I'm going to choose to look at one large rectangle and subtract the corner that's cut out. So we need to work out these missing lengths. So on the right here we've got a length that would be 9 minus x plus 1, the difference between the left hand and the right hand sides, and that gives us 8 minus x. And on the top we've got the difference between 14 and x, so that would be 14 minus x. So we can write our equation 9 times 14 minus 14 minus x times 8 minus x. That represents the area of the large rectangle minus the part that's cut out, and that gives us 54. Once we've written down that equation, we can multiply out the brackets, remembering to keep the minus outside of the brackets to make sure this is correct. Then we can distribute that minus as well and simplify. So we get a quadratic x squared minus 22x plus 40 equals 0. So we're looking for two numbers that multiply together to give 40, add together to give minus 22. That would be minus 20 and minus 2. So we get x minus 20 times x minus 2 equals 0, which gives us x equals 2 or x equals 20 as the solution. But our final step in these ones is to go back and check the context. We can see here 20 wouldn't make sense. You know, x plus 1 would be 21 and x would be 20. They would be bigger than the other sides and it just wouldn't make sense in this diagram. So it must be that x equals 2, which does make sense, and that would be our final answer here. This GCSE problem solving question is really tough. We've got two circles centered at P and Q. They touch at this single point and they fit exactly into this rectangle that's 25 by 18 centimeters. We're told the radius of the first disc is 8, and I want to work out the radius of the second disc. So let's call that second disc's radius x, and notice if we join the point P to the point Q, the centers of those circles, that gives us a line of length 8 plus x. And the key here is to make this into the hypotenuse of a right angle triangle. So if I extend and draw this right angle triangle like so, we would also look around the picture and notice that we've got those radii. Well, the radius of the large circle is 8 and the small circle is x, but we can find other ways of drawing the radii that will be very helpful. If I do them like this, the vertical orange side here will be 18, which is the vertical side of the rectangle, minus 8 minus x, because you can see in that vertical line we've just got those two radii of the different circles lined up. Similarly, horizontally, we've got 25 minus 8 minus x, and so actually the other two sides of the triangle here are 10 minus x and 17 minus x, and if we put that together with the hypotenuse being 8 plus x, we can write down an equation for x that we will be able to solve. We can do that by Pythagoras' theorem. 10 minus x squared plus 17 minus x squared equals 8 plus x squared. And then we just multiply out all of the brackets. 100 minus 20x plus x squared. 17 squared is 289, so I get 289 plus x squared minus 34x there. And on the right hand side, 64 plus 16x plus x squared. Now if you cancel terms, collect everything together on the left hand side and simplify, we will get the quadratic equation x squared minus 70x plus 325 equals 0. You might look at this and wonder whether it factorizes. 325 is 13 times 25, or 5 times 5 times 13. So if it does factorize, it could only be 1 and 325, 25 and 13, or 5 and 65. And it's that last one that works here. So we get x minus 65 times x minus 5 equals 0, which gives us possible values of x equals 5 or x equals 65. But in the context of this question, 65 doesn't make any sense. That would be way bigger than the whole diagram here. So it must be x equals 5. And we can see that makes this orange triangle a 5, 12, 13 triangle, another famous Pythagorean triple. If you found that useful, I think you'll want to watch this video next. It's a similar video with several questions on functions. Another one of those really tough GCSE and IGCSE topics that will make the difference for grades 7 to 9.